Okay, today's lecture is on enzyme kinetics experiment. So, we are going to measure the kinetics of trypsin enzyme. All of these chemicals that you need for this can be found in these cabinets here. Okay, trypsin starts with a T, so we're going to look in the cabinet that has a T on the door. Okay, I know you can figure that out. All right, so we've got trypsin, and this one here is the substrate for the enzyme. N-alpha benzoyl DL-arginine 4-nitroanilide. Okay, and what is this? This is a peptide analog. Okay, basically what this has, you notice that I mentioned arginine. Okay, so there's an arginine and there's a site on this molecule that trypsin can cut. And what does it do? It cuts off para-nitroanilide. Para-nitroanilide has a yellow color. The substrate has a slight yellow color, but not much. So once you cut it, it has a bright yellow color. It absorbs at, I believe, 310 nanometers. It might be 340. I'm sorry, I forgot. It's in the procedure. So check that procedure for the actual wavelength that you'll set your spectrophotometer to. Okay, but anyway, so the point is, this substrate has a very low solubility in water. So how are we going to make our substrate solution? We are going to dissolve it in dimethyl sulfoxide. Dimethyl sulfoxide is an organic chemical. We store it in the flammable storage cabinet. So you're going to get that. And DMSO is very hazardous. No, I am wearing gloves, and you need to do the same thing. Okay, so you're going to dissolve your substrate in dimethyl sulfoxide according to the instructions on the procedure. And then, after you prepare that solution, we're going to come over here and we're going to move this camera around and show you, right over here is my handy-dandy enzyme substrate mixer. Okay, so we're going to turn it on. You're going to put your dimethyl sulfoxide with the substrate in here. Okay, and you're going to put it into this thing on the side like this. There we go. And you're going to turn it on. And if you can see, this does end-over-end mixing. Okay, so this will be the first thing you do. You're going to put there, and it won't degrade because it won't degrade in the dimethyl sulfoxide. So you're going to just let this turn for a while, and then you're going to come back over here, and we're going to continue making solutions. Right. So that's the substrate solution. And we also need to prepare a combination of the substrate solutions. And that's going to be done, the buffer that you're going to use for your enzyme experiment is tris buffer. Okay, so the pH that you're going to make your tris buffer at is going to be different. You're going to do different pHs. And the idea is, as you may recall, that enzymes have different activity at different pH. Remember that, how the protonation, depending on the pH, changes, and that makes the enzyme more or less active at different pH values. So, according to the procedure, you're going to prepare tris buffer, okay, at different pH values. So how do we do that? You prepare let's say you want to make a 50 millimolar tris buffer. Okay. And this also has some calcium chloride in it, according to the procedure, right? So to make the tris buffer, let's say you want to make 40 millimolar. So you're going to weigh out enough tris to make 40 millimolars, okay? And if you want to make, let's say, 500 milliliters of buffer, you will only put in water to, say, 400 milliliters. So you leave extra room, and then after you prepare that, you're going to pH it. How do we pH it? With hydrochloric acid. This is 37% hydrochloric acid. That's very concentrated. So you would do well to dilute this a little bit before you mix it into, try to make your tris base with it, because you may overshoot the pH. It's hard to get it right on, spot on, with a very high concentration of HCl. So you want to use a slightly lower concentration of HCl to prepare your tris buffer. All right, again, gloves, because this is dangerous. Right, so what you do is you take that buffer, that you make that tris dissolved in the water, and then you're going to add HCl to it until it becomes a pH that you want it, right? When that happens, then you add the calcium chloride that is necessary for that 500 mils of buffer, and then you finish by putting the water up to the 500 mils that you designed your buffer to be, okay? So you can do that, and this is an important skill, is making buffers, so you need to do that, and it's important that the pH be accurate. So once you have your buffer and you have your substrate solution rolling away over there, okay, then we are going to prepare the enzyme solution. Trypsin is a protease. What does that mean? What kind of molecules does trypsin chop up besides N-alpha, benzoyl, DL-arginine, whatever it is? Okay. What kind of molecules does it chop up? It chops proteins. So that means it chops itself up, which is a problem when you're doing enzyme kinetics. Because that means that the activity is going to go down, and that is not a result of the trypsin being inactive, it's a result that it chops itself up. So what you need to do is keep it very cold and then act fast. So when you have all of your other solutions ready and you're ready to start measuring the kinetics, then you prepare your enzyme solution. Okay? So you're going to weigh out the trypsin, and you're going to weigh it out into 0.001 normal HCl. And how are we going to do that? We are going to use the handbook of chemistry and physics and find out what is the concentration in molarity of 37% HCl. And we're going to find that out, and we're going to use that information to prepare 0.001 normal HCl. This is available in the book cabinet over to the side of the lab. Right. Then, once you have that enzyme solution mixed, it's going to be cloudy, and part of that is because this is laboratory grade trypsin, so don't worry about it, just keep going. Okay. Then, you're ready to do your enzyme kinetics. A different presentation shows you how to use the spectrophotometer, but you're going to prepare your cuvettes, and you're going to want to, you don't put in the enzyme until you're absolutely ready to stick it in the spectrophotometer. So that enzyme is the last one to go in, because remember, you want to measure initial rate. You want to measure the initial rate of the enzyme. So if you leave the enzyme in there for a while, then some of the substrate has degraded and the concentration of the substrate has gone down, and you are no longer measuring initial rate. So this is an important point. The last solution you're going to put in there is the trypsin. So read that procedure carefully and understand how you are supposed to prepare your cuvettes with buffer, with some substrate, and when that's ready to go, then you put in the trypsin and you measure the kinetics right away. So this is a team project. You do this together in a team. Identify who's going to be the one responsible for assembling the cuvettes, who's going to be the one responsible for measuring the enzyme kinetics, and all that sort of thing. This cuvette, by the way, you want to use the semi-micro cuvettes in the spectrophotometer. They have one perfectly optically clear side, crystal clear through one side, and the other side is not optically clear. So you want to make sure that you put it into the spectrophotometer with the optically clear side through the light path. Okay. We also have these cuvettes that have 4 optically clear sides. Those are fluorimeter cuvettes. Don't use these in the spectrophotometer. Okay, so I think you're good to go, and I will work with you on collecting the data at the end of the lab. Great!